have obtained the integration function by cumulative addition of incremental variable, which is obtained by multiplying the rate function of the time step. When delta t tends to 0, the process is called the integration of the rate function. So here we can see that we have the cumulative addition, so 2 of n plus 1 is 2 of n plus delta t. So likewise, for each point we will be having a cumulative function, so that is given by the integration. Now we will find the rate function by successive subtraction of integration function to get the difference value and divide by the time. When delta t tends to 0, this process is called the differentiation of the integration function. So that now we are going for the reverse process, differentiation of the integration function. So we are finding the difference of the integration function. The difference is delta t. When I divide by delta t, so when delta t tends to 0, then I get the differentiation function. So that is q of n plus 2 minus q of n divided by delta t. So when delta t tends to 0, so that becomes a differentiation function. So here we can take our problem what we have discussed. So in this we have calculated the value of q. This volume of the locations, spread locations. So we added not here, q here, q4. So now what we have to do is we have to find the difference of the integration function. So here first value we have calculated q4, next value is q. So q4 minus q3. So it is 4 minus 3, which is equal to, similarly q3 minus q. So that also it is 3 minus 2, which is equal to 1. Similarly q2 minus q. So which is also 1. And q1 minus q1, that is 1 minus 0 again. So we find delta q is equal to 1. And we can find out what is slope. Slope is delta q divided by delta t. So which is 1 divided by 1, which is equal to, so here the slope is constant, and if the value is equal to 1, the slope at the delta t tends to 0, that will become the differentiation of the integration function. Next we can go for the smaller delta t. So now delta t is 0.5. Here also this function also we have integrated. We have calculated values at all the cases. So for q0, q1, q3, q4, q5, q6, q7, q8. So now we can find the difference of the functions. So q9 minus of q8, so 0.5, that is 4.5 minus q, so 0.5. Similarly q8 minus q7, so this is also 0.5. So like that we can proceed. So everywhere we have to get 0.5. So I have q minus of q1, which is also 0.5. So now we find delta q is 0.5. Now we can find out what is the slope. Just delta q by just 0.5 divided by the delta t is also 0.5. Now the slope is 1. And when the slope delta t tends to 0, it's the differentiation of the integration function. So further we can proceed. So now here we are dividing the total integration. We are dividing into so total time is 5 minutes. So we are dividing it by 0.2. So the total time is 45 steps. So that means 25 q's we calculating. It will be starting with q0, which is equal to 0, and the end value to 24. So here also you can calculate what is q24 minus q24. So this value is 0.2. So similarly q23 minus this is also. So that q1 plus this is also 0.2. Now we have delta q is 0.2. Delta t also here is 0.2. So 0.2 by 0.2 is equal to 1. So the slope is constant, is equal to 1. And the slope at the delta t tends to 0. So this becomes equal. So that is how in this case we will just discuss the case of the linear function. We are not going to go here, but if you go for a complex functions, so then finding slope will be difficult. Only when delta t becomes 0, you can define the differentiation of the integration function. So thus we can summarize that the integration is the cumulative addition of the variable by multiplying the rate function and the delta x. And we have seen the equation for the cumulative rate function, cumulative addition of the variable. And also we can summarize that the differential rate function is the difference between the successive integration function, which is divided by delta x. And for that also we have seen the expression. So this delta delta y by delta x. That is y of n plus 1 minus delta y of n divided by delta x. You can dy by dx, so delta x tends to 0. Thank you.